All right, welcome to the second of our talks in this room. Our second talk is by Laura Richter, Making Jupyter Notebooks Less Awful. You can take it away.
Hi everyone. Thanks for having me at PyCon today. Um, I'm gonna have my video on for a few minutes and then turn it off and begin into the presentation just for the sake of bandwidth. Um, yeah. So uh, I started working on this talk and fell down an absolute rabbit hole of people having opinions about Jupyter Notebooks on the internet. So I already knew people had opinions, but wow, there are a lot of opinions on the internet. Although it does seem like it's died down a little bit. Um, in the last few years. But I thought I'd take you through a little tour of some of the opinions people have on the internet before jumping into how to make notebooks better. Um, so this was a paper in Nature, amazingly, in 2018, which had many wonderful things to say about Jupyter Notebooks. You know, killer app for teaching, um, powerful connections between topics, theories, data, and results, computational narrative. And my favorite of these, which I actually think is the reality, is de facto standard. You know, nowadays anyone, pretty much anyone who's working with data and visualizations of data is using a Jupyter Notebook. So 2018 de facto standard. But even in this very glowing article about Jupyter Notebooks, they had some not so great things to say, which is that Jupyter Notebooks also encourage play coding practice by making it difficult to organize code logically, break into reusable modules, develop tests to ensure that code is working properly. Notebooks require discipline. So there you have it. Even the most glowing report has some uh, not so glowing things to say. Then the next year, 2019, nice Google blog about Jupyter Notebooks. Um, This is actually a great blog. I put all of these references at the end if people want to go check them out later. Um, I like how this one puts it. Because they're relatively recently developed, they don't yet follow or encourage consensus-based software development best practices. And I think we've all seen that and can attest to that. And the next thing is data scientists, typically collaborating on a small project that involves experimentation, often feel they don't need to adhere to any engineering best practices. And that I think we can all attest to. That's absolutely true. Um, you know, no engineering best practices for us. We're moving fast and building things, building creative things. And this one in Technology Radar, this is 2020. This one was particularly scathing because it basically just says, don't use notebooks for anything important. Encourage data scientists to move to proper coding mechanisms. Um, so that one was particularly harsh. And then I did a little rabbit trail about Reddit, and there were many things in Reddit. Lots of people, their hatred towards Jupyter Notebooks, Jupyter Notebooks are trash. Notebooks suck, change my mind. Um, but the one called I Don't Look Notebook Like Notebooks in the middle here was actually a particularly wonderful talk at JupyterCon a few years ago. I've put the link at the end if anyone wants to go listen to that. It's a little bit out of date now, but um, a really good step-by-step walk through why notebooks are actually not ideal. Um, so given that there's so much hate towards notebooks and notebooks encourage such bad practice, why do we use them? And going back to that original one, they are the de facto standard. So we are using them. They're sort of the evidence is in our behavior. They're obviously useful. Even though they have, you know, all these bad qualities. So it's because they're useful for a whole bunch of the things that a bunch of current job roles need. They're good for prototyping, they're good for experimenting, they're good for presenting and teaching, learning. They're good for environments where you have to take your compute to the data, where your data isn't on your laptop, it's somewhere else, and you need to be able to interact with it in a visual way. In fact, anything that needs a visual result, notebooks are what people just end up using. It's frankly is the best tool or the de facto standard. And while reflecting on this, I remembered a great incident with one of my former managers. Was this great guy, um, very smart, but from a computer science background rather than a sort of sciencey background. And we used to have to do a lot of work on data sets, so processing of data and modeling and so on. And he used to make these most amazing visualizations in the terminal. He'd print out amazing tables and data that showed where things were happening in time, all just from the terminal. And it was incredibly impressive, but it always used to make me laugh because I thought, God, if you just follow the graph, your life would be so much easier. So yeah, I think even even roles that aren't directly data science or data analytics nowadays, a lot of things need visual results, and when we need them, Jupyter shines. Um, so in my poking around, I found this 2020. It's a bit old now. The 2020 Jupyter survey by the Jupyter people. Um, And this just confirms this. The survey is very interesting, actually. They asked all sorts of questions, but amongst them was just, what are you using Jupyter for? And it's exactly what we would expect. It's visualizing data, doing some cleaning and preparation of data, machine learning things, some pipelining things. What people aren't using Jupyter for is the bottom layer of things, which is developing um, applications and code, which is as you would expect, visual things are where Jupyter shines. So we have all these people who have visual needs in their coding. Um, when does it get to the point where you need good practice? So I just pulled these words out of some of those articles earlier. So when do you need good practice? So if you're working on a larger project, if you're working with lots of people and collaboration becomes important, continuous integration becomes important with now lots of people. When you're building a bigger system, where it's something that can't just be contained in one notebook, when you're actually having to deploy things and having to sort of monitor and test and so on. So this is what those articles said, but I'm actually gonna disagree with that a little bit and say, actually, you need good practice whenever you need something to be correct, to be reliably correct. You need good practice, and this can be anything from an analytics notebook. You're processing some sales figures or whatever you're doing as part of your analysis. You're looking at the web traffic over time to get monthly active users, analytics type tasks, or modeling type tasks. With modeling tasks where you need a visual component, you're driven to a notebook, you need it to be correct. And the way I think of this is, back in the day, I was a physics undergrad. I'm not sure if other people have experimental science background. But back in the day, in a physics practical, you'd have a lab full of whatever equipment you need for your particular prac. Maybe it's some diffraction grating you're measuring something through. And you sit there for hours learning how that piece of equipment works and learning all of the subtleties and the causes of error. And, um, you know, you have to take into account parallax when you do your measurements and so on and so on. And that's none of that is considered extra. It's not considered style, or we wouldn't even call it good practice. We'd just call it correctly using the instrument you're using for your science. Um, and I think of good practice in code in the same way. We just need to be uh, using our instruments in the right way to make sure that the results that we're getting are correct. And in order to do that in code environments, you need good practice, which unfortunately we have in the Jupyter world a little bit of a history of not doing so well. And I stole these two examples from that I don't like notebooks a talk from JupyterCon a few years ago, which was in the Reddit page. Um, so there's some great interactions in that talk if you want to go and have a look. But these two are just on the left. There's a tweet that basically is saying data science doesn't need good software engineering, because it's about, experimenting and, you got to be creative and iterative. And then on the right, someone is saying buggy code is bad science. Poorly factored code is bad science. It hinders reproducibility and increases chances of a mistake. Um, and all of which is true. And I might even go, so far as to add myself, being good at the instrument you're using and making sure that you're using it accurately for what you need is part of science. It's not an extra thing. Right. So, um, now that we've spoken all about notebooks being good and bad and what people think about them, um, how do we make our notebooks more correct? And I'm going to flick through a few different topics, and in each case, I'm going to just tell you about some of the tools you can use. I'm not really going to go into depth, because this is more of a review of the tools that are available. And the order here was very difficult to choose because a lot of these things are quite integrated with each other, or interconnected with each other. So the order is really not that important. We'll talk about things a little bit in circles. But before we go on to stepping through that list, just briefly to say, where are you running your Jupyter? And I found in the course of doing research for this talk, I found the most wonderful site. I can so recommend it. It's called datasciencenotebook.org. It's managed by one of the online Jupyter providers, but nonetheless, it's a really good list. It's up to date. On the left here, you can see a list, and the list is considerably longer. You can go and compare different hosted notebook providers with each other to see what pricing models they have and what features they will have. I highly recommend it. But just to quickly talk through it, I try to put different places you can run Jupyter into some categories. It was quite tricky to put them into categories, but the first one is sort of yourself. So you're running Jupyter. You're running it locally on your computer with Jupyter or Jupyterlab. Maybe you set up a Jupyter Hub instance, but it's still you managing it really. Or you using Jupyter and VS Code. And I was actually really sad not to be able to make the VS Code talk that's happening right now. So I'm very interested to hear why we shouldn't use VS Code. But for the moment, I'm going to say VS Code for running Jupyter, which I think is becoming increasingly popular actually, because you can use all of the keyboard shortcuts you're used to and the environment and setup that you're used to, and it can make you quite, significantly more efficient if you're working like that. So that's the common way to work now. Then we get these sort of, I didn't know quite what to call it, but these sort of lightweight hosted notebooks, which are things like Google Colab, Binder, which lets you run notebooks on public Git repositories, like actually run them, Kaggle kernels, which is similar sort of thing. And these ones are all more for, learning, teaching, a quick thing that you want to share with someone. You probably could build out something useful with Google Colab, but generally these are quite lightweight. Then we get the sort of, I'm calling it medium weight, but there's a lot of online notebook providers nowadays that give you nice integrations and nice collaboration tooling, the ability to comment on each other's notebooks. These are ones like DeepNote, Satin Cloud, JetBrains. There's lots of them. The one that we experimented with for a while is DeepNote, and it is very nice. But you're paying for your compute, and depending on whether or not you want to do that, it might be more efficient just to work on a laptop, which is what we found in the end. But they are very nice, and a lot of them have integrations with things like GitHub and so on. Then you get your enterprise hosted, and I call it enterprise hosted because these are the ones that sort of fit into some bigger ecosystem of, your entire cloud-based system of Amazon or Google or Databricks, and often come with a whole sort of ML platform and so on. And you can actually use VS Code to run things here too. You can just connect VS Code to a remotely running notebook, which can actually be quite a powerful, convenient option for people. And then you get a whole lot of niche ones. So Paperspace Gradients, that's more of an ML platform with the ability to parameterize things, CoCalc for learning and teaching, mode analytics, and other analytics packages which have notebooks as part of the analytics. NAS.ai is an online platform that their sort of speciality is big libraries of templated notebooks. So there's all sorts. Basically, there's a million billion ways you can run your Jupyter. And I partly wanted to put these up just to say which one you choose will give you a different level of control in how you can set up your environment. So, you're working on your own computer, you can set it up entirely. Some of the hosted ones don't have all of the features that you might want for good coding practice, or they might take a little bit more effort to set up. So that's just something to keep in mind when you're evaluating which one you might use. A lot of them do have great integration, but some of them don't. So something to keep in mind when you're evaluating. Right, so moving on to tools. Tools for software development, good practice. So why echo that tweet? My code doesn't need to be pretty. My code doesn't need to be pretty. Move fast, experiment. No time for aesthetics. Why would I be bothered with aesthetics? And the answer, of course, is, all of these answers would be whole conversations, but code is read more often than it's written. Style actually supports quality. If you want quality, you do things in a consistent way, and a lot of style and good practice things actually come out of, they come out of supporting quality at the end. And I'm not actually going to go into these components of good practice because I don't consider myself an expert and talk is more about tools. But just to say briefly, as someone who's becoming better at their instrument of writing code in Jupyter Notebooks for whatever end use case you have, some things to keep in mind and to learn over time are writing clean code. Put some resources at the end of the presentation. Just a very sort of next step one after you've first got used to writing code in a notebook is to start moving functions from notebooks into modules as appropriate. Especially if you're working on larger projects with lots of functions, notebooks that use similar processing, multiple notebooks, larger projects that have multiple people working on them, move your functions into modules. Then the Python style guide, of course, and the Zen of Python. If you haven't seen this before, go type import this and you will be told it has some wonderful things like explicit is better than implicit and simple is better than complex. But now onto tools. So, in terms of software development good practice, the tools that I've used that I can recommend are the automated code quality and analysis ones. So I've just put a list of a few here. I thought Flake8, Black. These are linting and formatting tools. Linting is a sort of static analysis piece that that looks at your code and checks for whatever that particular linter is specializing in. So in the case of iSort, it's are your imports in a particular specified order? Are your in the case of Flake8 and Black, it's more style formatting, adherence to PEP8 style guide rules. So, oh, and just to say, I put SQL Flap in this list just as like a little head nod to SQL Flap, even though it's not Python at all, just because I love SQL Flap. If you write code in SQL and have SQL files, go check out SQL Flap. So the nice thing about these is that some wonderful person has gone and made them work with notebooks using a tool called nbqa. Now you can run nbqa, iSort, Black, Flake8, and a whole host of other ones. These are the three that we use, and they're probably a good place to start. So I just put a little couple of examples of each one. Flake8 just does linting, which that's just the checking component and telling you what's wrong. And you can see an example of a terrible notebook on the left, or a terrible notebook cell on the left, and some of the things it's complaining about on the right. And then Black does both linting and formatting. It's a formatting module, so it'll actually go and fix the sort of style errors or inconsistencies in your notebook for you if you just run Black on something, and then you can also run Black in check mode to check against the formatting rules. And then finally, I thought just sort your imports. And just to have a little plug for these things, before you use them, you think they're a waste of time, or at least I can say I did. When you start using them and get used to the kind of code they produce, it's just so much more readable, so much, there's so much more consistency and ability to quickly notice errors. Really, I highly recommend this. And also, things like Flake H often pick up um, proper errors. So things like having imports that you don't use, things like having variables that you don't use, which are very possibly pointing to actual errors in your code. So it really does, it is a big value add. But for version control and reviews, um, yeah, the reviews just slow me down. I'm doing things. Um, yeah, we know if that's considered a problem for us, we probably need to be slowed down. Um, And I just wanted to say something about version control for Jupyter Notebooks. I'm going to be speaking about GitHub just because of what we use, but of course you could use whatever version control system you want. I think for notebooks, um, version control gives something slightly different to what version control gives normal software development. So in normal software development, it's this continuous integration piece. So people are working in the same bit of code, and you need to all be able to do your own thing and check against each other and deal with mergers and so on. Jupyter Notebook development, in my experience, it's more about creating dated artifacts. So you do a piece of work and you want to record that that piece of work was done at this time with this result. Um, that's more the use case that I've found it for. And so we talk about version control, but we're actually sort of using version control tools for something slightly different. And so the first thing I'm going to say is just use a version control tool. We use GitHub. You can use whatever. Um, Then the next step is that use whatever Git tooling you're used to. So if you just want to use a command line or if you want to use Git tooling in VS Code, but if you aren't sort of used to using those, you can also there's a really great Jupyterlab Git extension. It doesn't work for the most recent Jupyterlab, but works on the previous one. Some of the other ones work on the current one too. Um, and a lot of hosted notebooks also have this Jupyterlab Git extension in them, so you can get started using it there. And then moving on to get diffs. So diffs are a real pain in the butt for notebooks. One solution to that is a nice little package called nbdime. So nbdime strips out all of the sort of extraneous notebook diff stuff and just gives you important things. And it also gives you a visual interface if you want, or as you can see on the right. But it almost feels a bit sad to have to say this. nbdime has actually been it's a victim of its own success, and now GitHub itself uses the nbdime in the background to do its own divs. They're still on feature preview. If you don't have this feature sort of set up, you can go and set it up, and the link is in the end of the talk. And then you'll actually get proper diffs within your notebooks. As you're doing reviews on GitHub, which is way better. Another option is a tool called nbdev, which is this huge suite of tooling, almost a framework for how you develop code in notebooks. And it has some nice tooling around merging, and it also does some things around having hooks that strip out certain bits of metadata that cause confusing merge conflicts. So it strips out things like execution counts. It strips out, you get your matplotlib things with the link to the x00 blah 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 one in your matplotlib output. It sort of strips all that out for you so that you aren't having to deal with those sort of non-real diffs, shall we say. So that's a nice option. But uh, I just wanted to say about nbdev, it's its own whole ecosystem for developing code in Jupyter Notebooks. And if you're starting a new project, it might be worth trying this out. I've never really leaned into this, but it gives you a framework for everything from writing your code in notebooks and then automatically also converting it into a py file. There's testing, there's automated document creation, documentation creation, really a nice module. And now I'm realizing I'm massively running out of time, so I'm going to have to be quite quick for the rest of this. So the problem with all of these is that they don't actually give you the ability to comment on each other's PR requests, which is such a big limitation actually, because that's the whole reason for a pull request is actually interactivity, or pull request review interactivity. You can, of course, just go, put comments in the main section of your review, but not being able to put inline comments in a notebook where you want to address something is quite a real limitation. So one nice tool for that, but this is a paid tool, sort of SaaS tool, is called ReviewNB, and that lets you actually go put inline comments in notebooks, and it integrates with most of the major version control systems. Okay, first thing, flick through this quickly. Why do we need to test? Just write your code properly the first time. And in answer, I offer you this crazy piece of code. I have been caught by this in the past. I know other people who've been caught by this in the past, but if you have tried to make a thresholding function at some point, which I think a lot of us do in the data science world, and then you passed in a number, and then you passed in a number that came out of a NumPy array, and realizing that NumPy true is not the same as a Python true. That's a very deep thing to try and figure out. If it's in, one of many little pieces of code in a long notebook. So this to me is the answer of why you need unit tests, because things like this happen. Yeah, more often than one would think, and the problems that they cause, or the incorrectness they might cause in your model or your analysis, might be very non-obvious. Making sure that your code is correct is actually a valuable thing to do. So flick through. I'm just going to tell you about all of these. nbval and nbmake are both tools you can run your notebook through that actually run the notebook end to end. They look for errors, so an actual crash in your notebook, error messages in your notebook. And nbval also then compares the output cells of the notebook that you give it with the output cells of the new run. So these are great sort of almost entry-level ways of testing a notebook. Just confirm, does your notebook actually run? Yes, it does. Does it give the output you expect? Yes, it does. Have you gone and done some weird out-of-order things that have changed the behavior? No, good. So those ones will check that. Testbook and PyTest Notebook are more actual testing suites. Testbook in particular actually gives you a way of writing tests of a notebook in an accompanying file of tests, and they're both PyTest plugins. That's sort of the next level if you actually want to test individual pieces of your code, like functions. And nbdev, again, is its own whole ecosystem that includes some pieces around testing. Right, automating. So you decide that you and your team want to move towards these best practice things. The easiest way to make it easy for you and for you to actually therefore do it is to automate as much of it as possible. And the great thing is that there's a lot of tooling to do this. So once you've figured out, we want to use these linting components, put it in some GitHub actions. Put some of it in GitHub pre-commit hooks or in Jupyter save hooks. GitHub actions will run things triggered by GitHub. So, for example, as you push something, you might have your linting or your notebook testing be triggered and run in GitHub actions. We do that for our linting mostly. Then you'll get an error at the end that won't let you get a review in until you go and fix your linting or whatever it is. Pre-commit hooks will run some code before you actually commit. So this could be something like doing your linting. It could also be something else like stripping out metadata. That's actually what nbdev does. And you can also have Jupyter save hooks, which as you save, run bits of code. Oh, actually, this is what nbdev does. nbdev uses a save hook. So actually, it's as you save, the metadata gets stripped out. And on the right here, there's just a little example of a GitHub action for running PyTest. We actually don't use, in our team, we don't actually use GitHub actions for PyTest because we're reliant on data that isn't in GitHub. So what we do instead is we run our testing through a pre-commit hook. So the actual end-to-end nbval test is done that way. Right, okay. Not much more left. Dependency management. You know, we know we need to do it. And if you haven't yet hit up a problem where you're looking at a notebook from 2 years ago and all the requirements are different and the jolly thing doesn't run and you have to spend a day figuring out that it's because of some, pandas in backwards not compatibleness, then, it's going to happen to you if it hasn't yet. So the deal here is the normal software development stuff. So first of all, always work in a virtual environment. And your requirements. So have a requirements.txt. Possibly use something else like pip compile or some other version management to make it a little bit easier for you to not just be creating a requirements file from pip freeze every time. And just to say, depending on the cloud environment you use, you can often set things up to use an exacting environment in your cloud environment too. So don't let yourself be lax just because you're working on the cloud. You can do the stuff too in the cloud. And then finally, the sort of next level is Docker. And then you're pinning everything down to your operating system. And the only thing I wanted to say here is just that my preference or recommendation is the base Docker environments that have a whole lot of stuff pre-installed. It might be nice just for some experimenting, but actually you really want to know the exact version of everything, and you want to be able to have deliberately chosen these are the versions I want of these things, and in 2 years or 2 months it's going to be these versions. Using those ones that come with stuff pre-installed actually just will make life harder for you in the end. And using a base Jupyter Docker and then installing from your own exacting requirements file, it'll actually make life a bit easier for you in the long run where you have more control. And then data management, final one. Why bother? I just stuck my colleagues with CSVs, it works fine. We've all done it. Yeah, and we know it often doesn't really work fine. So the thing here is really to use some kind of centralized version of data. On one end, just use a cloud provider, so either put your data somewhere where it can be pulled programmatically across your team, so S3, your Google Cloud storage, but also maybe you're already working with data from the cloud, in which case, rather than downloading it and having it on your hardware and moving it around, just do the work programmatically in your notebooks. GitHub LFS is for large file storage on GitHub. If you'd like to use that as an option, that might be a good option if you're using notebooks to teach, something like that. Bulk data is a great little one I actually just found yesterday, which is sort of a layer on top of versioned S3 that gives you a way to pull S3 really nicely programmatically and have sort of structured data sets. And DVC, of course, is good for lots of things, but amongst other things, version control for your data and a nice layer of sort of consistency over maybe having your data in S3 or Google Cloud or whatever. And we actually use Google Cloud Storage in our team, and it's really effective. You just put your data up there, and it's in one place. Your whole team can do it, can use it, and then we have some simple scripting stuff to pull it consistently. Right, final thoughts, and then I'm done. Um, so there's lots of tools, and actually, the more I looked, the more I found. When this talk got longer and longer. So this is even just a whirlwind tour. It's not everything. So I thought I'd leave you just with a recommendation for where to start if you haven't started with any of this. So I'd say start with simple dependency management. First of all, virtual environments. When you've got used to using them, you'll wonder why you ever didn't use them. And requirements files. And for cloud notebooks, uh, be consistent. Use the same types of requirements and make sure that your colleagues are all using the same requirements, possibly by using the same GitHub integration in all of your online cloud notebooks. and then keeping the requirement files up to date that way. Next, auto formatting and linting. Again, it's going to be a real pain in the butt when you start because you're unused to it, but as soon as you get used to it, you will never look back. And next, version control and reviews, and getting used to doing reviews for each other. Again, hard at the beginning, but once we're used to it, such a big value add. Next, automate all of this as much as possible. So at the very least, automate your linting. Next, data management. So stopping sharing CSV files around with each other. And next, I would say simple end-to-end testing, probably with something like nbval. Down the line, maybe you want to actually be writing unit tests for bits of your code, especially if they're starting being moved into other systems that are relying on them. But to start out, just make sure your notebooks all run end-to-end. There's no errors, there's no weird out of orderness, and that's a simple enough thing to do just with something like nbval. Right, that's me. Sorry for going over time.
Right. Thank you very much for the talk. We still do actually have a few minutes for questions. So,
hi, thank you for a really, really interesting talk. I think very useful. On the subject of being useful, just a suggestion: would you, if you haven't already, consider publishing something, even just a blog post, and also maybe making your slides available under CC BY or something like that? Because I could imagine myself using some of those slides and sort of spreading the gospel, as it were. And then the actual question, there was on one of the slides you put in, you flashed up, there was something that mentioned Quarto. I think it was one of your, it was nbdev or something like that. So I don't have any real experience with Quarto, but I wondered if you've talked a lot about how Jupyter Notebooks can be made less awful, but are there alternatives like Quarto?
I haven't actually tried Quarto myself. I tried nbdev once, and they have a great system where if you also have Quarto, your code sort of gets made into this beautiful automated documentation. But I haven't experimented with it beyond that, so I can't answer. Sorry. There are some other notebook alternatives which people could potentially try. But I don't really have an opinion because I haven't tried them. Sorry, that's a not good answer. But I can say that I put most of the references up that I used in the talk up at the end of the note, at the end of the talk. So I will definitely share all of these because you can go and choose whichever ones you want yourself. There's some good resources here.
any more questions? All right, let's thank the speaker.
Thank you.